What I have here is the Ellwood method of generating a cap rate, and my purpose of doing this recording is to explain it in more detail. What you have is a property here generating initially $369,648 of net operating income, but growing at 3% per year. It turns out that that's the equivalent of $408,465 over the expected holding period of 10 years. And this is how I calculated it. I take the NOI and I grow it by the growth rate assumed to be 3%, I believe. It gives me a present value. I take the annuity that's equal to that present value, and that's how I get 408,465. Now if I change this growth rate, let's say you put it in at 0, I'm going to get something close to the initial number. In fact, it's exactly the same number. If I put in 2%, we get 395. If I put in 3%, we get 408,465. The real value of using the Elwood method is, one, it does generate a realistic cap rate. But two, we can take cap rates from the market. In this case, the final cap rate that's derived is 7%. And we can ask the question, what required rate of return, in this case 15%, matches up with those cap rates we observe in the market? Or what combination of equity yield, required rate of return, and growth rate in the NOI match up with that? And I could come up with a combination of NOI growth rates and equity yield target growth rates that would exactly match up with the cap rate, and that would be pretty powerful information telling me what investors in the market are assuming. Those are the two most critical assumptions here, because the financing is pretty much a given. It is what it is in terms of what's available and what the terms are, but it's the growth rate assumption and the required rate of return that are often unknowns. So this method lets us generate those, and then we can use those to help generate future cap rates as well. The other inputs that I need here are the mortgage rate, in this case 5.5%, or 5.5% divided by 12 for the monthly rate, 25-year term, or 300 months. The loan to value that's assumed is 75%. And these terms should be based upon what's available in the marketplace for the kind of property that we're valuing. The monthly mortgage constant is given here, which is the inverse of a present value of an annuity factor. And if you multiply it by 12, you get the annualized mortgage constant. What that is, for every dollar of loan, you'd have a payment of 7.369 cents approximately per year to pay it off in 25 years. Now, even if the loan is a 10-year term, it's the amortization term that we need for the mortgage constant and for estimating the principal repayment. Continuing on with the calculations, here I assume a transaction cost of 5%, but it could be 6, 7, or whatever is realistic in the market. And I take that same appreciation rate, 3%, and I use it to estimate my gross appreciation calculation as follows. If the property NOI grows at 3%, then the value of the property, without changing the ratio of yield to price, would be 1.3439 times the initial property value, simply growing it at 3%. The net is estimated here by knocking, in this case, 5% off of the gross asset to come up with a net appreciation rate of 27.67%. And that's one of the sources of returns that Elwood considers directly. We're going to consider the cash flow from the property, the appreciation rate, and the equity buildup from paying the mortgage down. All of those are going to be considered separately. We're also considering the growth rate in the NOI explicitly by using a stabilized annuity for the NOI. So this is a very realistic present value approach that uses the equity yield based on when the return is being received, not based upon some generalized estimate of it, but it's timed precisely. The other calculations are as follows. To do the Elwood method, I need to estimate how much the appreciation is worth to me on a level compounded basis. So I need a sinking fund factor, which is defined as how much do you have to put away per period to generate $1 in the future. And in this case, at the equity yield rate of 15%, we need to put away this calculation right here, 0.049 of a dollar per year for 10 years. Growing at 15% will give us $1 at the end of 10 years. Now we're going to use that for adjusting both the appreciation that we expect to receive net and for the principal repayment on the loan. And so that's another calculation we have to make right here. The proportion of loan repaid is based upon the present value of the remaining mortgage balance after 10 years. And so this formula right here is 1 plus a negative present value of the remaining loan, and the result is that approximately 24.84% of the loan will be paid off. And that return is going to be received, in this case, at the end of 10 years. Of course, it might be received earlier if they refinance, and maybe I should use a shorter holding period if that was going to be more typical. Let me show you how I use these calculations then. The essential Elwood formula is given here in this greenish box. It's the loan-to-value ratio times the annualized mortgage constant, and that is part of my weighted cost of capital right there, the 0.055 number. It is the equity proportion, 25% down, times the equity yield, and of course we can change those numbers. So I get my return required on equity. It is the principal repaid. You see there the 24.84% paid off number, times the proportion of the property that was financed, times our sinking fund factor. So to the extent that I get my cash flow return here from the NOI, I adjust the cap rate downward for the fact that I'm also getting an additional return from the principal repaid. I'm going to do the same thing with the appreciation right here. This net appreciation times the sinking fund factor. And so what this means is that to the extent that I get more appreciation, I need less cash flow to come up with my 15% yield. To the extent I have loan repayment, I need less cash flow to come up with my 15% equity yield. And so that's why both of those numbers are negative. They bring down the amount that I need to get initially. Elwood has something called the basic rate, which is simply without considering appreciation. In this case, that cap rate is 8.359%. Here you see it in decimal form. But when I add all these together, my cap rate is 7%. And if I saw 7% in the market, then again, it would match up with a 3% appreciation rate and a 15% equity yield. Let's go ahead and change that right away. And we'll see some of the effects if we would change that assumption. Let's say the market only requires a 12% target return. Watch the cap rate and watch the value. The value is around 5.8 million. The cap rate's at 7%. The cap rate goes down significantly when I lower the equity yield, and the property value goes up significantly. What happens if I lower the appreciation rate to 0.02%? I lower the value of the property, and the cap rate changes as well. Let's make this 1%, and you see that the less appreciation we expect in the future, the less we're willing to pay per dollar of income now, and therefore the cap rate goes up. The more I expect to get in the future, the more I'm willing to pay per dollar of going in income. And that's what that cap rate tells me, the value of the property per dollar of going in income. Notice there's a problem here, though. If we're borrowing 75% at 5.5%, the debt coverage ratio the first year is 96% of the net operating income. That means that there's not enough money to pay this loan. And we're going to have to bring that value down to get this up. And that's another sensitivity analysis. What value would we have to achieve a debt coverage ratio of, say, 1.25? And so that may be a constraint on value, and that's why we should point out not only a table of trade-offs between the growth rate and NOI and the equity yield, but also the effect on debt coverage ratio, which most lenders are going to want to be at 1.25 or so. So let me go ahead and change this to 0.15. And now I'm at 115% debt coverage ratio with a lower value and less financing. And 1.15 might fly if the underwriter is kind of lenient, but it might also be a little bit too low. We could continue to play with the equity yield. That would achieve a high enough number, and maybe 1.20 is enough, but it did bring the value down. Now, of course, we might also question this growth rate in the NOI, which is why an extremely valuable output would be to take a given market cap rate and say what kind of required rate of return, leveraged that is, required rate of return, and growth rate in the NOI would match up with that cap rate, and that'd be valuable information. But also, it'd be helpful to have a chart of DCRs that you get with different values, because there's only so much mortgage that any given property can support. So this would be really useful output and extension to this particular cap rate. But that basically explains what's in the calculation. Thank you.